So finally, we know how to integrate. And now that we know how to integrate, let's see how we actually use integration to find the area under a curve. To do that, we use a concept called definite integrals, where instead of merely integrating f of x with respect to x, we integrate from one point A to another point B. So if the integral of f of x with respect to x is equal to f of x, then integrating from A to B would mean that we're going to be taking f of B and subtracting from it f of A. So let's look at an example. Now, you must remember when we were trying to find the area under the curve x squared from 0 to 3. So let's see how integration would allow us to do that. Integrating x squared obviously gives x cubed over 3. Now we're integrating from 0 to 3. Now the thing is, with definite integrals, you don't need to write the constant of integration, and you will see why in a few seconds. So substituting 3 into this expression here gives us what? We have 3 cubed over 3 minus 0 cubed over 3. If I had the constant of integration here, we'd have the plus c, yes, and we'd have the plus c here and the minus c, and it would cancel. So because the constants of integration cancel when you're doing definite integrals, there's no need to bring in that constant when we're doing definite integration. So what do we get here? We get 9 minus 0, which tells us that the area under the curve x squared between x equals 0 and 3 would be 9 units squared. So let's look at another example. So let's say that we wanted to find the area under the curve x over 2x plus 1 to the 3, or to the third power, from 0 to 1. Now we're going to be using substitution here, but I want you to take note of something. I want you to take note of how using substitution in doing definite integrals actually affects the limits, the 0 and the 1 that we have here. We call those limits. So we're going to be saying u is equal to 2x plus 1. So du over 2 would be equal to dx, and x would be equal to what? U minus 1 all over 2. Now, before we go any further, remember we're integrating from x equals 0 to x equals 1. But the aim of substitution is to replace all the variables that we're integrating with respect to with the new one, which is u in this case. So if x is equal to 0, then u would have to be equal to what? Substituting x in this, u would have to be equal to 1. Now, if x is equal to 1, then u would have to be equal to what? Again, substituting it in this, then u would be equal to 3. So that means then that if we're integrating with respect to, if we're integrating this expression here with respect to u, where u is equal to 2x plus 1, then we would be integrating from where? From 1 to 3. But what exactly would we be integrating? We would be integrating u minus 1 all over 2 times u to the negative 3 with respect to u. And let's factor out that half. And let's go ahead and simplify so that we can integrate this. So let's factor out the other half there, leaving us with u to the negative 2 minus u to the negative 3 with respect to u. So integrating that now gives us what? We're going to be left with a quarter times negative u to the negative 1 plus u to the negative 2 all over 2 from 1 to 3. So let's do our substitution now. So that gives us what? 1 over 4 times, if we substitute 3 in this here, what do we have? Negative 1 over 3 plus 1 over 18, and we need to subtract the substitution of 1 in this expression now. So what do we have? That would be negative 1 plus 1 over 2. And what does what does that leave us with? That leaves us with 1 over 18 units squared. In other words, the area underneath, area under what? Area under what? The area under this curve from 0 to 1 is 1 over 18 units. And we were able to solve that by substitution. And we're going to be looking at one final interesting example. We want to integrate from 0 to pi over 2. What do we want to integrate? We want to integrate 4 sine 6x sine 2x with respect to x. You can remember the product to sum rules that we looked at some time ago. And we're going to be factoring out some stuff here and using that rule. So what are we left with? We're left with 4 over 2 times the integral from 0 to pi over 2 of what? Cos 4x minus cos 8x with respect to x. Now, that leaves us with 1 over 2 times, if we integrate this, we get what? Sine 4x over 4 minus the integral of that, which should be sine 8x over 8. And we're integrating from 0 to pi over 2. Now, when you substitute this, when you substitute these expressions, when you substitute x equals 0 and x equals pi over 2, you will notice for yourself that this is going to sum to 0. Now, you're supposed to be thinking a curve, and there is no area underneath the curve. That is impossible. So how exactly were we able to get 0 here? Point of information, this 0, the working out, the actual integration process is not wrong. The actual integration process that we carried out here is not intuitively wrong. The answer that we got, however, is wrong. Why? We will see in the next video. And these are some of the laws of definite integration that you can take a look at.